Hi guys, today we're going to continue our work with circles and we're going to build on what we did yesterday and the day before with area. Today we are relating the circumference and area to each other. So first we're going to be using circumference to find area. In order to do that, we are going to plug in all of our known values to the circumference formula. So remember, our circumference formula is C equals pi times diameter. And then we want to isolate our variable by using opposite operations. So remember, we're going to use those inverse operations to help us solve. We're going to use the new information to find the area using our area formula, which is area equals pi times radius squared. All right, so we're going to do some practice together. And we're going to figure out how we can use what we know about circumference to help us find area. So first, we have the following problem. It says a circle has a circumference of 22 meters. We want to know the approximate area, so we're probably going to do a little rounding here. And we want to use 3.14 for pi. So what we know is the circumference is 22 meters, and I know that circumference equals pi times diameter. All right, well, we just said circumference is 22, so instead of C, I'm going to put 22, and we also said we're going to use 3.14 for pi times diameter. So basically, I'm going to solve for my diameter here. In order to do that, we're just going to solve our equation. So draw our line down the equal sign. And I'm going to divide both sides by 3.14. On the right, that's going to cancel out. And on the left, I am going to get approximately 7. So when I do 22 divided by 3.14, that is going to be about 7. So my diameter is about 7. Now, I can't use diameter directly in my area formula. So I want to convert my diameter, which is 7, to radius. And I know that radius is diameter divided by 2. It's half. So I just need to do 7 divided by 2, which gives me 3.5. So I'm going to use a radius of 3.5. Now that I know my radius, I can plug that into my area formula. Area equals pi r squared. And again, I'm using 3.14 for pi times 3.5 squared. And if you remember from the area notes, we want to make sure we do our exponent first, or our multiplication over here first. So 3.5 times 3.5, or 3.5 squared, is 12.25. So I am going to be multiplying 3.14 times 12.25. When I multiply, I get the answer 38.465. And remember to include your units, so that is going to be meters squared. So I started with circumference and I ended up with area. I took circumference to find my diameter, changed my diameter to radius, and then used radius to find my area. So we're going to do that same process again for number 2. A circular pool has a circumference of 61.9 feet. What is the area to the nearest square foot? So nearest square foot means I'm going to round to the nearest whole number of the bottom of the pool. And again, I want to use 3.14 for pi. So again, they tell us the circumference. So I'm going to start with my circumference formula, which is pi times diameter. And I'm going to plug in what I know. Circumference is 61.9 feet, and pi, we are using 3.14. So again, I'm going to divide by 3.14 on both sides. And that is going to leave me with a result. It's actually going to be 19.7, or about 19.7, but I am actually going to change that. I'm going to round it because, again, it says nearest square foot, so we are going to round that up to 20. So D is approximately 20. And remember, radius is diameter divided by 2. So I'm going to do 20 divided by 2, which is going to give me 10 feet. So my radius is equal to 10. Now that I know my radius, I'm going to take that and put it into my area formula. So area equals pi times radius squared. Again, 3.14 for pi times 10 squared. And I want to do the exponent first. So 10 times 10 is just 100. So I'm going to multiply 3.14 times 100. I can put that in my calculator, but since I'm multiplying by 100, really I just need to move my decimal point 2 places to the right. So this is going to give us an answer of 314 square feet. Okay. So for the rest of the problems, we're going to kind of change gears a little bit, and we are going to use ratios and patterns to find circumference and area. So I'm going to scroll down and we're going to take a look at this table. I'm going to go ahead and delete my little video here just so we have enough space and you can see everything and I can write this all in. All right, so we're going to complete the table. We're going to describe a pattern in the relationship between the ratio A to C, so area to circumference, and the radius. So we want to look for that relationship. Over here, we're looking at this comparison, A to C, and over here in simplest form. And what we want to do is make sure that we look for that relationship. How are they related to the radius? So we're going to come back and relate that to our radius. Really, we're going to complete the chart first. So given a radius of 4, the area, remember our area formula is pi times radius squared. So we're going to do pi times 4 squared. 4 squared is 16, so 16 pi. And since they don't tell us to use 3.14, we're just going to keep it in terms of pi, of the symbol pi. So we're going to leave it as 16 pi. And then our circumference is pi times diameter. Now we have radius over here with 4, so I'm just going to double that. 4 times 2 is 8, so 8 pi is our circumference. And then we're going to write it as a ratio here. So I'm going to put area on top, 16 pi over 8 pi. And then if I simplify that, my pi's would cancel out, and I would be left with 16 over 8, which I can simplify to 2 over 1. All right, so let's look at a radius of 6. If I have a radius of 6, I'm going to do 6 squared, which is 36, times pi. So 36 pi. For circumference, pi times diameter. My radius is 6, so my diameter would be 12. So my circumference would be 12 pi. If I want to write my comparison here, my ratio, I'm going to have 36 pi over 12 pi. Again, my pi's would cancel, and 36 over 12 would reduce to 3 over 1, or just 3. And up here it was just 2. For a radius of 8, I'm again going to do pi times radius squared, and 8 squared is 64. So I have 64 pi for area. If my radius is 8, 2 times that is 16. So 16 pi is my circumference. Again, I'm going to write this as a ratio, 64 pi over 16 pi. Pi would cancel. 64 over 16 would simplify to 4 over 1, or just 4. And then a radius of 10, pi times radius squared. Well, 10 squared is 100, so it would be 100 pi. If the radius is 10, the diameter is 20, so this would be 20 pi for our circumference. And if I write that ratio, it would be 100 pi over 20 pi. And that is going to simplify to 5 over 1. So you probably are seeing a pattern here, especially with this column here. But we're going to really look at how do they compare. So what we are finding, and what you should be able to notice, we want to see what is the comparison of this here, of this column, A to C, our area to circumference, that ratio, to our radius. And what we can find out is that area over circumference is going to be equal to 1/2 our radius. If you look, 2 is half of 4, 3 is half of 6, 4 is half of 8, 5 is half of 10. So what we are seeing here is that A over C, I'll write that over here, is equal to 1/2 times radius. And we could look at this a little bit further. And if I scroll down a little bit here, if I were to look at, for example, a radius of 32, right? We're looking at this as radius times 1/2 would give us 16/1, which would be A over C. So we can calculate this A over C just by multiplying our radius times 1/2. So over here, I want you guys to write out A over C equals area over circumference. And A over C equals 1/2 times radius. So this is actually pretty helpful. If we know this, that this ratio exists, if we know how to find this, if we know our radius, then we can find our ratio of area to circumference by just multiplying our radius by 1/2. Okay, so we are going to continue doing some work today. We've got a little activity after this. If you have any questions, I know some of this can be a little bit confusing, especially looking at it as a ratio, but if any of this was confusing or if you need any clarification, come see me and we can work through it. Or if you have any questions about your next activity, definitely come back and ask for help.